Okay, this is EGR-225, Circuit Analysis 1 lab. This is experiment number 2. In the first part of the experiment, you're asked to take and measure some power supply voltages. I'm going to instead measure some DC voltages from some batteries. So I got to turn my meter on. We got an Agilent meter here, and I'm going to have to take and change its function to DC volts. So I take a AAA battery and attempt to put my probe on it, and what do I see? 1.541 volts. Being a AAA, a very small one here, this little one, turns out it's not going to be able to supply too much current. Here's a D battery, so let's see what the D battery does. The D battery gives me 1.592 volts. Of course, they're made the same way. This one would supply, it's bigger, it would supply more current for a longer period of time. I thought I had it. There we go. Here's a double A, not a triple A, but a double A. So the double A, I'll take and make a measurement here, and 1.592. This guy and this guy, this is a smaller double A. They appear to be brand new batteries because they're given a very high voltage. Here's a 9 volt, Energizer 9 volt, and this guy here, I'll take and put my leads on it, and true to its name, 9.006 volts. I'm going to flip my leads around. Right now you see a little plus on the display there to the bottom. By the way, notice this voltmeter has a bar graph on the bottom. I'm going to flip my leads around, so if for some reason you were to measure the voltage backwards, that is a polarity, look what happens. This big minus comes up, now minus 9.006 volts. So measuring voltage is polarity involved, especially obviously if it's DC. I've got this guy here is a battery for a portable piece of lawn equipment. So let's see what happens here. I think I have to go across like this, and sure enough, well, I got them backwards, so let's go like this. We'll flip the leads around, and 20.39 volts. And so again, this guy here, I'll show you what the heck it is. This is a battery that goes into a piece of, it's a Ryobi, goes into like maybe a weed whacker or something like that. 20 volts. This one, by the way, let's see what it says. Lithium, 18 volts, 4 amp hours. 4 amp hours means if I have an 18 volt battery, you would multiply volts times amps, and you could get whatever combination that is to last for 4 hours. If I got 1 amp out of this battery, it's 18 volts, that's the 18 volts. 18 volts times 1 amp, I would only get a fraction of an hour use out of it. If I was getting a tenth of an amp times 18 volts would be 1.8, and I could get about well, over 2 hours of use out of this battery. So you can get more current for a short period of time or less current for a longer period of time. And batteries are, again, listed as amp hours. Okay, thank you.